Okay, in this video, we're going to detail completely all transformations of a function f of x using function notation. So we're going to help make sense of this, each part of this function, which was originally just f of x, causes some transformation on the graph. And we're basically going to show where each one of these transformations take place. So I'm going to start by going to the calculator. So just going to the calculator, and I'm going to define f of x. Okay. All right. Let's use the absolute value function. So I'm going to go menu 1 1, menu 1 1, and I'm going to define f of x as the absolute value. Absolute value, I'm just using a weird function. So absolute value of x. And we'll just press enter. All right. Just we can change it to anything that we want. Okay. Now that we have f of x defined, we can go now to our graph. And I am going to make f1 of x to be f of x. So I'm going to variable, enter, and f of x. Okay, so that's the absolute value function, and which is our f of x. That's our parent function. So now let's define another function. Now let's look at all the transformations of f of x. Okay, so go to f2 of x. First transformation we'll look at is we'll change the value of a. So I'm going to talk about, let's keep it simple. What does negative f of x look like? So I'm going to go negative f of x. All right? We'll get to a in a minute. All right. So when you make f of x negative by putting a negative sign in front of it, it gives you a reflection about the x-axis. So this is a reflection. So f of x, so negative f of x, I'm just going to see if I can just make this. F of x is reflected about the x-axis. That's what negative f of x does. It reflects f of x. So about the f-axis. So the first transformation we talked about is reflection. All right. The next reflection of f that we're going to look at is what happens if we take f of x and we multiply it by some number a. So a of f of a, not a of f of x, but a times f of x. All right. What happens? And so we need to create, I'm creating a slider. So we're just going to put in different values of a here. So, and I don't want this to take up a whole lot of space, so let me minimize this. All right, so notice that if a is 1, nothing changes because multiplying anything by 1 doesn't change it. But what if I let a be bigger than 1, like 2? What happens when a is 2? Well, when a is 2, the graph gets skinnier. That's what it is. Let's compare this with the original graph so that we can see. So I'm going to put the original graph back in here. That's in blue. That's our parent function. Look at our transform function. It's skinnier because a is 2. What if I let a be 3? Even skinnier. What if I let a be 10? Even skinnier. So the bigger a is, if a is greater than 1, the graph is going to be skinnier. It's going to be made more narrow. We call that a vertical stretch. So if a is greater than 1, you have a vertical stretch. Now, what happens if A is less than 1? All right, well, in this particular case, let's let A be, I'm going to let A be like 1/2. So I'm going to put a 1/2 in here, or 0.5. I'll just make it 1/2. What if A is 1/2 between 0 and 1? Now you see the graph is getting wider. So, and if I notice that if I let A get smaller, let's make it 0.1, very, very wide. Now, what if I let it go negative? Then we're reflecting it again. So, so we got 3 things that we know about A. If A is less than if A is between 0 and 1, you're going to have a vertical compression. That's what we call it, compression. All right. Keep in mind that if A is negative, if A is negative, which is the same thing as just putting a negative sign on it, you're going to have a reflection. So this is what we need to know about A. Now, there's another type of transformation that happens when we multiply the x values in the function. Not the whole function, but just the x values by a number. So what if we just, inside of the function, multiplied x by some number b? Of course, we know that if b is 1, which it is right here, there's no change in the graph. But if I let b bigger than 1, b be bigger than 1, then the graph gets narrow again. The only difference is that this is actually, we call this type of, we don't call this a vertical stretch. We call this a horizontal compression. So it looks like a vertical stretch and it can be confusing. But just for the sake of you understanding the notation, whenever b is bigger than, and let me go ahead and try that. Whenever b is bigger than 1, we're going to call that a horizontal, because it's happening from x probably. Horizontal, and we call this a horizontal compression. It's like someone squeezing it from the sides, and so that's why it gets skinnier. All right. So, and same thing happened if I let b be equal to, let's say, 1/2 or 0.5. I'll put that in there, 0.5. Then we get the same. We get a horizontal stretch now. So when b is between, and so I keep wanting to do that for some reason. When b is between 0 and 1, you're going to have a horizontal stretch. Horizontal stretch, like someone's pulling it from the sides, which looks just like a vertical compression. I know it's confusing. Okay. Now, of course, b can be negative. Let's see what happens when b is negative. When b is negative, and let's see, in this particular example, it may be hard to see. So what if I just let b be -1 and I hit enter? Okay, you can't really tell. It looks the same. And that has to do with the fact that we're using the absolute value function, which essentially gets rid of the negative function. So I have to maybe use a different example to show what happens when b is negative. Use a different type of function, because you can't tell it with this function. Okay, so there might be a separate video. Okay, and so we only, now that's 3, so we got those. But what's supposed to happen, what you don't see at this graph, is that when b is negative, and I'll go ahead and at least tell you this, when B is negative, or when there's a negative sign on the B, I'm going to say when B is less than 0, or the negative sign of it, you have a reflection again, but this time, and because you can't see it in this graph, reflection about this time the y-axis, and that's because this graph is symmetric, you can't tell. If I get a graph that is not symmetric, you can see this, but because the graph is symmetric, you can't see. All right. So we only have two more types of two more types of transformations left. All right. So here's our original function again, f of x. And this time we want to consider the transformation f of, and 109 there. What if we added something to x instead of multiplied, like 5? What happened? The graph moved 5 units to the left. And look what happens if I subtracted 5 from x. The graph moves 5 units to the right. So that tells us, this gives us our horizontal translations. Okay? So this lets us know, and I'll just go ahead and just type this, that that if you subtract, if you have a minus there on the C value, I guess it would have been better if I made it C. But if C is positive, the graph moves to the right. If C is negative groups of graph, we're going to say that's a right transformation. Or did I stumble there? And then if we got a plus, then that's going to be a left. So these are horizontal translations. So, all right. So you can see this really easy probably if I made it like, let's make it general. Like what if I put a C here and I put a plus? See there. See, and I make it a slider. And see, notice what happens when C is positive. When C is positive, the graph is moving to the left. When C goes negative, the graph is moving to the right. So that's what happens with the number that you either add or subtract from C. And then while I'm at it, let's also look at the last transformation, and these are all pretty easy. Let's just add another graph page here. And this time I'm going to put in f of, oops, I don't want to store a variable. I just want to open one. Okay. Oops. Escape is your friend. Gets you out of trouble. All right. Oh, the reason why I was doing that because I did that. All right. So let me borrow f one more time. And first of all, let's graph f. Let's get f back up. Get our parent function back up one more time. And now we want to look at this transformation where we're talking about f of x. And this time I want to deal with outside the parentheses. What if we add a number to the whole function like that? All right. I don't want to use C. We've already used C. Let's use D. All right. Boom. Then I create a slide for D. Notice that, and it came out in orange. Notice what happened if I add something to D, to the function, and it's positive, the graph is moving up. And if I subtract something from the function, the graph is moving downward. So that is our vertical translation. So if we got plus, that's going to be up. And if we have a negative number added to the function, then we're going to have a downward translation. So that is all of your translations. So let's review all the translations when you deal with this. We notice that the negative sign here lets us know that we have a reflection. All right, the negative sign by itself lets us know that. So I'll put an arrow right there. Okay. Ooh, that doesn't look like an arrow. Let's make it look like an arrow. That's better. All right. There. Okay. The A is our vertical compression. If A is between 0 and 1, then we have a compression. The graph gets wider. And if A is bigger than 1, then we get a compression. We get a stretch. So A controls these two. Okay. All right. I really one arrow would have sufficed. Let's see. There. Then let's look at, of course, let's look at B. If B values control our compression and stretch also, but from the horizontal direction. Really the main thing you want to worry about is that if B is negative, the graph will be reflected about the y-axis. So all this has to do with, let's use the negative and positive for the reflection, and we'll use the B for the compression. There. And then same thing with C. C controls the left and right. So I'll go ahead and pull this over here and right. And let's put some arrows there. So if it's plus, then we're doing left. So I'll just put it right there. Okay. And if it's negative, the graph is moving to the right. All right. And then same with the vertical compression, vertical translations. If D is negative, if there's a minus sign in front of it, then we're moving down. And if D is positive, then we're moving up. And that is all of our transformations of f of x. Let me